Saya guna
Mana?
MATLAB yang question tadi.
Ini,
Yang
okay.
YP itu kan. Yang saya guna MATLAB kan, dia tak sama dengan menu calculation saya. Tapi yang dua sama, saya boleh terus skip YP itu.
Macam mana? Macam mana?
Yang YP itu tak sama dengan menu calculation saya. Sebab dia mungkin kami ambil yang XY tak sama kan.
Okay.
So saya terus skip YP, tapi yang dua tu sama answer dengan menu calculation saya. Saya
tak dengar. Sorry.
Hello?
Hello? Ya.
Dengar tak? Yang saya boleh terus skip YP ya?
Tak boleh.
Yang
nak skip YP?
Yang saya guna YP dia tak sama dengan menu calculation saya.
Kenapa tak sama?
Sebab kami ambil yang tak sama kan, XY tu. Tapi yang final answer sama.
Okay, saya faham. But your final answer sama kan?
Yang
okay.
Initial
Okay,
condition.
saya faham.
Terus saya terus skip YP tu lah.
Ya. Tak payah skip, you buat je. You letak je dalam you punya report.
Okay. Thank you.
Okay. Nanti final answer dia adalah yang kat sini. Nanti. Kalau sama, maksudnya samalah you punya. Ni sebab dia ada XY tu dia beza kan. Kalau you ambil lain,
berbeza.
dia akan jadi lain. Okay?
Okay, thank you.
Okay. Okay, ada soalan lagi? Tak ada. Okay. So, can we proceed with the class? Kalau tak ada soalan? Okay. So, now is a tutorial chapter 3. Okay. Question number 1 is show that, okay, you have to show that Y1 and Y2 is the solutions of first order linear differential equation. Okay. So, you have to prove that this, okay, this Y1 and Y2 is the solutions of this Y1 prime and Y2 prime. Okay. So, macam mana you nak buat? So, macam mana you nak solvekan dia? Okay. Okay. Okay, look here we have Y1 prime equals to Y1 plus Y2. Okay. So, number 1. Okay. You have Y1 prime equals to Y1 plus Y2. And Y2 prime is equals to, okay, 4Y1 plus Y2. 4Y1 plus Y2. Okay. So you have to prove that this Y1, okay, and this Y2 is the solutions of these two system. Okay, of this system. Okay. So Y1 is equals to exponent 3x plus exponent minus x. Okay. So you have Y1 exponent 3x plus exponent minus x, while Y2 is 2 exponent 3x minus 2 exponent minus x. Okay. You have 2 exponent minus exponent 3x plus exponent minus x. Okay. Okay, so what you need to do is, okay, so here you have Y1, here you have Y2. Okay. Okay, so Y1 prime, okay, this one Y1 prime, okay, you masukkan this Y1 and Y2 inside this equation. Okay. Ya, awak masukkan Cik nak masukkan Y1 prime equals to Y1 plus Y2. Okay, and then you masukkan this y1 to here and y2 here. Then what you get is a exponent 3x plus exponent minus x. Okay, okay, plus y2 is 2 exponent 3x plus exponent minus x. Okay, okay. So equals to this one plus this one, you get 3 exponent 3x plus exponent minus x plus exponent minus x. So 2 exponent minus x. Okay, so this is what you get from y1 prime. You gantikan, you replace y1 and y2 inside this equation. Okay, and then you have to compare. Okay, you have to compare this one with this one. Okay, y1 prime. You differentiate this y1. Okay, so once you differentiate this y1, what you get is exponent 3x. You differentiate, you will get 3 exponent 3x. Exponent minus x, you differentiate, you will get
Negative exponent negative x.
negative exponent negative x.
Doktor,
Ya,
dia dua eksponen negatif X kan?
yang mana
Negatif
Okey,
yang
okey.
Y2.
Y2 ke? Y2. Saya salah tulis
Yang kan betul tak? Dia
Y2. Salah. Okey. 2 eksponen. Okey. Thank you. Tolak 2 eksponen. Mana? Yang ni
yang tu.
Okey, thank you Tolak 2. 2 apa tadi? 2
Eksponen
eksponen minus 2x. 2 eksponen minus x. Betul? Jadi sini salah lah kan? Sini tolak 2. So sini jadi eksponen dengan tolak ni jadi tolak x. Okay, ini baru betul. Okay, so you ada y1 prime. Okay, if you replace y1 and y2 inside these equations, you will get this one. Okay, while you have y1 and then you differentiate this y1, you will get this one. Okay, you can see from here, this y1 prime and y1 prime here is the same. So y1 and y2 is the solutions of this linear differential equation yang ini. Okay, and now we have to prove this y2 prime. Is it y1 and y2 is the solutions of this? Okay, so we just repeat the same procedure. Okay, so now we have y2 prime. Okay, so what do you have for y2 prime is 4y1 plus y2. 4y1 plus y2. Okay, so you replace y1 and y2 here. Okay, for y1 is exponent 3x plus exponent minus x. Okay, plus y2 is 2 exponent 3x minus 2 exponent minus x. Okay, so if you kembangkan this one, you will get 4 exponent 3x plus 4 exponent minus x plus 2 exponent 3x minus 2 exponent minus x. Okay, so 4 exponent 3x plus with 2 exponent 3x, then you will have 6 exponent 3x, betul? Okay, plus 4 exponent minus x minus 2 exponent minus x, then you have 2 exponent minus x. Okay. Okay, now you have to prove that this one is same as this one. Now we have to find the differential of, you have to differentiate this y2. Okay, so you differentiate y2, what you get is 2 exponent 3x. You bezakan, you akan dapat 6 exponent 3x, and then minus 2 positive kan, plus 2 exponent minus x. Okay, so kalau you comparekan this y2 prime and this y2 prime, okay, it has the same equation kan? Sama kan? Sama tak?
Sama.
Sama kan? Okay, so once you get, okay, you prove that y1 prime and y2 prime, okay, this one. So last kali mesti ada y1x and y2x is the solution of system. Okay. Okay, you have to put this sentence. Okay, otherwise you lose 1 mark from here. Okay, so y1 and y2 is the solutions of the system. Okay, it's some kind of macam you punya kesimpulan. Okay, now I conclude that y1 and y2 is the solutions of the system. Kalau you tak buat yang ni, okay, kita tak tahu you provekan apa yang kat sini. Okay. Okay, faham Okay, yang nombor 2 tu boleh selesai. Ya, saya.
Nak cakap faham.
Nak cakap faham, okay. Okay, so nombor 2 tu saya tak payah tunjuk sebab soalan dia senang je kan. Caranya sama je. Okay. Okay. So now we move to question number 2. Okay. Sorry saya ada background music, background kat belakang anak saya ada. Okay, so number 2 is find the general solutions for the following system of first order linear differential equations. Okay, so saya tak nak buat yang, okay, actually dia ada 3 soalan je kan, A, B, C. Saya salah ni okay, so A, oh sorry betul lah ni, A, B, C, D, E. Okay, Y1 prime, Y2 prime here. Okay, so couple dia kat sebelah sini okay. So saya buat yang, saya pilih yang senang je Ini ada perpuluhan, saya tak nak nanti you all buat sendiri Saya ambil nombor 2 Okay, B. So you have once y1 prime equals to minus 10 y2 and y2 prime equals to 5 over 2 y1 minus 10 y2. Okay, so we try to solve this system. Okay. Okay, so number 2. Okay, you have y1 prime. Y1 prime equals to minus 10 y2. Okay. And then y2 prime 5 over 2. Okay, so if you want to solve this one is a homogeneous or non-homogeneous? Homogeneous or non-homogeneous? Okay, homogeneous kan non-homogeneous? Homogeneous kan? Sebab dia tak ada G dekat belakang. Okay, so first step, okay, if homogeneous, so which mean you have to find Y, YP or YC?
YC.
YC, so you have to find YC. Okay, so to find YC, okay, first you kena buat dalam bentuk, you have to arrange, okay, in a metric form.
C.
Okay, and then you have to find eigen value, okay, and then from eigen value you can find eigen vector. Then you have to prove that this one is linearly independent or not. Okay, and then you can get the general solution. Okay, if you are given the initial condition, then you have to find the constant value. Okay, okay, so now we arrange this one into a metric form. Okay, so we have a y prime. Okay, y prime is here we consider as a y1 prime, y2 prime. Okay, we have here, okay, this one is y prime equals to a times y. Betul? Equals to a times y. Okay, so a, what do you have for a? You have a 0 minus 10, 5 over 2 minus 10. Right, and then you have y. Here is a y1 by 2. Okay, faham?
Faham.
Faham Okay. Okay, this is the first step, and then second step is we have to find the lambda. Okay, so to find the lambda, okay, 0, you have to minus with lambda, and then you have minus 10, and then you have 5 over 2, okay, then you have minus 10 minus lambda, okay, this one equals to 0, okay. Sekejap Okay, then now we have here is a 0 minus lambda times minus 10 minus lambda minus 5 over 2 times minus 10. This one equals to 0. Okay, so minus 0, 0, 0, 0, 0. Here is you have 10 lambda plus lambda square. This one 5. Okay, plus 25 equals to 0. So you rearrange this quadratic equation, you will get lambda square plus 10 lambda plus 25 equals to 0. And then you can use your calculator. Okay, here you have a lambda plus 5, lambda plus 5, so equals to 0. Okay, so your lambda is equals to minus 5. Betul? Lambda 1 and lambda 2 equals to minus 5. Okay, so you just have one lambda. Okay, so now from this lambda, we can get the eigenvector. Okay, so to find eigenvector, okay, you replace lambda minus 5 into this 0 minus lambda minus 10 minus lambda. Okay, so 0 minus, okay, lambda is minus 5. So here we have a minus 5. Here we have 10. And here we have 5 over 2. Here we have minus 10 minus minus 5. Okay? Okay? Okay, tutup kurungan. Okay, and here you have x and y. Okay, equals to 0. Okay, so 0 minus 5, here you have 5 minus 10, 5 over 2 minus 10 plus 5 minus 5. Okay, x, y equals to 0. Okay, so now this part you time this one equals to 0. So now we have a 5x minus 10y equals to 0. And the other one is we have a 5 over 2x minus 5y equals to 0. Okay, so this one is, okay, so you have y, okay, 10y equals to 5x and y equals to 5 over 10x or x over 2. Betul? Betul? Okay, this side pun sama kan? Y equals to 5y equals to 5 over 2x and then y equals to x over 2. Okay, so let's say let x equals to s, then your y equals to s over 2. Betul? Betul? You just replace x with s here. Then you get y equals to s over 2. Okay. Then your eigen vector, okay, equals to 1 over 2 s. Okay. Okay. So now you have, okay, metric lambda, this one. Okay, now you have to prove that this one is linearly independent or not. Okay, so you have a eigenvector here. Okay, this one eigenvector 1 and eigenvector 2 because eigenvector 1 and 2 is the same value. Okay, so now you have 1 over 2, 1 over 2, okay, equals to this one times this one, you have 1 over 2 minus this one times this one, 1 over 2. So this one is equals to 0. Okay, if this metric is equals to 0, what does it mean? Is it linearly independent or not?
Independent.
It's not linearly independent kan?
No.
Okay. Okay, what happen if this one is not linearly independent? You have to
No.
find E. Okay. Okay. Ingatkan ada step, dia punya step by step. If this system is not linearly independent, then you have to find E. Okay. So let's say, let eigenvector 1, this one is equals to E1 and equals to 1 over 2. Okay. Okay. Then we have to find E2. Okay. You have to find E2. Okay. So how to find E2? Okay. Okay. So how to find E2 is based on these equations A minus, okay, lambda times with identity metric. Okay. And this one times E2. Okay. Equals to E1. Okay. And let E2, okay, equals to A and B. Okay. Then kita masukkan. So we know what is A A we can get from here. Sorry. Kat mana tadi? From here, this one is your A. Okay. A minus lambda. So this is your lambda. Okay. Lambda and then times with I. This I is an identity matrix. Okay. Times E2. E2 is A and B equals to E1. E1 is 1 over 2. Okay. Okay. So we just insert what is A. A is 0. Sorry. Sekejap. Okay, so we have matrix A. A is 0 minus 10. Okay, 5 over 2 minus 10. Okay, minus lambda. Lambda is minus 5. Okay, times with I. I is an identity matrix 1, 0, 0, 1. Okay, and then times with darabkan dengan E2. E2 is A and B. And this one is equals to E1. E1 is 1 over 2. Okay. Okay. So here we have 0 minus 10. 5 over 2 minus 10. Okay. This one. Okay. Minus. Okay. This one times this one is minus 5. Okay. 0. 0 minus 5. Okay. Times with A and B and equals to 1 over 2. Okay. So kita selesaikan. We solve this one inside the bracket first. Okay. So what do we have here? 0 minus 5. So 0 plus 5 is 5. Minus 10 minus 0. So here minus 10. 5 over 2 minus 0. So here 5 over 2. Okay. And then minus 10 minus 5. So we have here minus 5. Okay. Times with A and B equals to 1 over 2. Okay. So up to this part, is it okay? Okay.
Okay.
Okay. Okay. So next is the method is the same as we find x and y. Okay. So this one you times with AB equals to 1. So now we have 5A minus 10B equals to 1. And the other one is 5 over 2A minus 5B equals to 1 over 2. Okay. So B is equals to A over 2, right? Okay, let's say, okay, A equals to S, then B equals to S per 2. Okay, if this case, then your E2, okay, E2 is equals to AB, okay. If we replace with this value, then we will have E2 equals to 1 over 2. Okay. Okay, so we have E1 and E2. Okay, now we have to find eigenvector 2. Okay, so this one is equals to E1 x plus E2. Okay, so E1 is 1 1/2 X plus E2 is 1/2. Okay. Then equals to this one times X is X plus 1 is 1 times X. So here is X/2 plus. Okay. So this is your eigenvector 2. Ada soalan tak? Do you have any question? Ada soalan? Ada soalan? Tak ada? Tak ada?
Tak ada.
Tak ada. Senang kan? Okay. So we have a lambda 1, lambda 2. Okay. And then we have a eigenvector 1, eigenvector eigenvector 2. Okay. So next apa kita nak buat? Next step is mana saya punya ni? Okay. This one dah. Okay, now we have to write the general solution. So the general solutions will be okay, y equals to okay. This one y is actually y1, y2. Okay, equals to C1. And then here we have you have what? Here? Saya tulis kat sini dulu C1 eigenvector 1 exponent lambda 1x. Okay, plus C2 eigenvector 2 exponent eigenvalue 2x. Okay, so now we have y1, y2, C1. This one is 1/2. Okay, exponent minus 5x. Okay, and then plus C2. Okay, this one is this one. Okay, so x plus 1, x/2 plus 1/2. Okay, exponent minus 5x. Okay, ada soalan?
Ada.
Tak ada. Faham?
Betul.
Ini saya.
Apa ni, kan yang untuk step ni, dia kalau dia equal to 0 kan. Kan untuk kelas minggu lepas kan kita buat not homo kan. Not homo dia semua tak linear kan. Tapi kalau dia linear equal to 0, kena juga ke buat step ni?
Macam mana? Linear equals to 0.
Tak, dia kalau dia macam ni new lah.
Doktor, dia buat macam ni sebab dia dapat value yang lambda tu 1 je kan?
Sebab bila you dapat eigenvalue dia satu nilai saja, lambda 1 sama dengan lambda 2, then kalau you provekan yang ini memang akan dapat kosong. Macam saya cakap last week ke saya cakap, saya ingat. Okay, sebab nilai dia sama, bila you tolak memang kosong. Kalau you dapat dua nilai lambda, kan? Kalau nilai lambda yang berbeza, you akan dapat ini nilai 1 dengan nilai 2 ni tak sama kan? Eigenvector dia tak sama, betul? Kalau nilai yang berbeza. Kalau nilai lambda yang berbeza, you akan dapat eigenvector yang berbeza. Kalau you ada eigenvalue lambda yang sama, lambda 1 sama dengan lambda 2, then eigenvector pun akan automatik sama. Betul? Kan? Bila automatik sama, you tolakkan dia, memang you akan dapat kosong. Okay, so ini case bila lambda 1 sama dengan lambda 2.
Okey, faham.
Okay. Okay, ada lagi tak soalan lain nak tanya? Tak ada. Tak ada soalan? Tak ada. Okay. Baguslah you all ni tak ada soalan. Okay. Next. Next nak soalan yang mana? You all semua dah try kan soalan ni kan? Dah try belum? Okay, kita try yang 3A pula Okay, so 3A is still homogeneous. Okay, but they have an initial condition here. Okay. You all dengar tak ada suara latar lagi kat belakang? Tak dengar kan? Suami saya tengah ada kelas kat atas tapi saya boleh dengar suara dia. You all tak dengar kan?
Tak dengar.
Tak dengar
Tak.
Okay. Okay, so kita tengok soalan 3. Okay, we look at the third question. Okay, find the particular solution for the following system of first order linear differential equations. Okay, so you're given this one. Okay. Okay, so y1 prime equals to minus 3, y1 plus y2, and y2 prime equals to y1 minus 3, y2. Okay, and the initial condition is y1 0 equals to 12 and y2 0 equals to minus 4. Okay, so if you are given the initial condition, then you have to find what is C1 and what is C2. Okay. If you are not given initial condition, you can stop up to this stage. Okay. Okay, so number 3. So number 3. Okay. Number 3, soalannya y1 prime minus 3 y1 plus y2. Y1 prime, okay, equals to minus 3 y1 plus y2, and y2 prime is y1 minus 3 y2, and the initial condition given here is y0, y1 0 equals to 12 and y2 0 equals to minus 4. Okay. Okay. So, macam biasa, you arrange this one into the metric form. Y prime equals to A. A is minus 3, 1, 1 minus 3. Okay. Y. Okay. And from here, okay, you can find the lambda. Okay. So for lambda is minus 3 minus lambda 1, 1 minus 3. Jatuh. Okay, equals to 0. Okay. Okay. Then here is minus 3 minus lambda, minus 3 minus lambda, minus 1 equals to 0. Okay. Kita kembangkan yang ini. Okay. Minus 3, then here we have 9 minus 3. Minus 3 ke? Minus 3 times it tambah 3 lambda plus 3 lambda plus lambda square minus 1 equals to 0. Okay. And then we have a 9 minus 1, 8 3 lambda plus 3 lambda plus 6 lambda plus lambda square equals to 0. Okay, so you rearrange these equations, then you have a lambda square plus 6 lambda plus 8 equals to 0. Okay, then you can use your calculator. Okay, you get lambda plus 4 lambda plus 2 equals to 0. Okay, then your lambda 1 equals to minus 4 and lambda 2 equals to minus 2. Okay, so this one, okay, you have a two different lambda. Okay, by default, we know that probably the eigenvector 1 and eigenvector 2 is different. Okay, okay, so now we have to find the eigenvector 1 from lambda 1. Okay, lambda 1 equals to minus 4. Okay, then you replace a lambda with a minus 4 inside these equations. Okay, now you have a minus 3 minus minus 4. Okay, 1, and then here is 1 minus 3 minus minus 4. Okay, this one is x, y equals to 0. Okay, minus 3 plus 1 is 1, 1, 1, 1, x, y equals to 0. Now we have a x plus y equals to 0. Okay, so let's say x equals to s, then y will equals to minus s. Minus s ke? Betul tak? Betul kan? Am I right?
Betul. Yes.
Betul kan? So you have x equals to s and y equals to minus s. Then your eigenvector 1 is equals to 1 minus 1 s. Okay, this one is your eigenvector 1 from lambda 1. Okay, now we move to lambda 2. Okay, lambda 2 equals to minus 2. Okay, so you minus 3 minus minus 2, 1, 1, minus 3 minus minus 2. Okay, x, y equals to 0. Okay, then minus 3 plus 2 is minus 1, 1, 1, minus 1, x, y equals to 0. Okay, now we have a minus x plus y equals to 0. Okay, so let's say x equals to s, then your y equals to s also. Okay, then your eigenvector 2, lambda 2 is equals to 1, 1. Okay, then kita tengok dia linearly independent ataupun tak. Here is eigenvector 1, this one is eigenvector 2. Okay, eigenvector 1 is 1 minus 1, eigenvector 2 is 1, 1. Okay, here, okay, this one times this one, 1 minus this one times this one, minus 1. Then you get 2. Betul? So, bila 2, this one is linearly independent. Okay, so bila linearly independent, you tak perlu cari E1, tak perlu. Okay, so you can just proceed with the general solutions. Okay, y equals to C1 eigenvector 1, okay, exponent lambda 1x plus C2 eigenvector 2 exponent lambda 2x. Okay, so now we have a y is y1, y2 equals to C1 eigenvector 1, 1 minus 1 exponent minus 4x plus C2 eigenvector 2 1 1 exponent minus 2x. Okay, up to this solution. Okay, okay, okay. Diam tu maksudnya faham lah kan? Okay, now you all diberi initial condition kan, y10 equals to 12 and y20 equals to 4. Okay. Okay, this means that when x equals to 0, y1 equals to 12 and y2 equals to 4. Okay, this one is a x value. Okay, so kita tengok, okay, first equation is y1. So y1 equals to, okay, y1 equals to c1 1 exponent minus 4x plus c2 1 exponent minus 2x. Okay, so y1 equals to c1 exponent minus 4x, okay, plus c2 exponent minus 2x. This one is y1 and y2 is c1 minus 1 exponent minus 4x. So here is minus c1 exponent minus 4x plus c2 exponent minus 2x. Okay.
Doktor,
Ya. Yeah.
Y tu sama dengan negatif 4 kan?
Yang mana saya salah kat mana Yang
Dia punya apa initial condition.
initial condition saya salah
Y2.
Y2 equals to?
Negatif 4.
Oh, negatif 4. Okay, thank you. Negatif 4. Okay. Okay, so now, okay, we want to use the initial condition to find C1 and C2. Okay, so look at Y1. Okay, so this Y1, when X equals to 0, so X 0, 0, then we have a Y1 equals to 12. So 12 equals to C1 exponent 0 plus C2 exponent 0. So now we have C1 plus C2 equals to 12. Betul? And this one, when X equals to 0, Y2 equals to minus 4. So now we have a minus 4 equals to minus C1 exponent 0 plus C2 exponent 0. Okay, so now we have a C2 equals to C1 minus 4. Betul? This one you bawa ke sini. Okay. So here, this one is equation number 1. This one is equation number 2. Then we put equation number 2 inside this equation number 1. Okay. So what we have here is a C1 plus C1 minus 4 equals to 12. Okay. And 2C1 equals to this one, 16. So C1 equals to 8. Okay. Okay, so C1 equals to 8. Then C2 equals to 8 minus 4 equals to 4. Okay, so now we have C2 and C1. Okay, we just insert this C1 and C2 inside this general solution. Okay, then you have Y equals to C1 is 8. Okay, 1 minus 1 exponent minus 4x plus C2 is 4. 4, 1, 1 exponent minus 2x. Okay, ada soalan? Do you have any question? You all tahu tak kat mana biasa guna benda-benda ni? Okay, biasanya you all pakai dalam analysis circuit. Okay, kalau you tengok dekat modul tu, okay, so this method kita boleh guna untuk selesaikan apa tu? We can solve the two loops punya circuit. Kan you ada belajar KVL, KCL apa semua tu kan? Kirchhoff law kan? Ada belajar tak?
Ya, ada Doktor.
Ada kan? So later what you learn in a map ODE, okay, most probably you will use in a signal and system and also control system because this is the prerequisite course for that subject. Okay. Okay. So semua faham ni? Ada nak tanya saya? Do you have any questions to ask? No question? Okay, number 4. Okay. This number 4 you can solve by yourself because it's a 3 times 3 matrix. Okay. Method dia sama. Except you have to do a long way for calculation. Okay. Okay, so we move to number 5. Okay, so number 5 is find the general solutions for non-homogeneous system of first order linear differential equation by method of undetermined coefficients. Okay, remember for chapter 3, okay, for non-homogeneous is only method of undetermined coefficients. However, for chapter 2, okay, for non-homogeneous equation, okay, you will have to solve using a method of undetermined coefficients and also variations of parameters. Okay, make sure you clear this one. Okay. Okay, so kita try buat yang ini. Okay, so 5A. Okay. Saya buat 5B lah. Okay, 5B. Okay. Y prime equals to 3. Okay, this one is your A. This one is your G. Okay. Okay, so first you have to find the Mama kelas sayang kejap Okay, so number 5 is y prime equals to 3, 2 minus 2, 1 minus 1. 3, 2 minus 2 minus 1, y plus, and g is 2 exponent minus x, exponent minus x. 2 exponent minus x, exponent minus x. Okay. So this one is a non-homogeneous. Okay. So for non-homogeneous, first you have to find for YC. YC is a homogeneous punya system. Okay. So you have to find YC. So to find YC, you have to find lambda. This one. Okay. So lambda is 3 minus lambda 2 minus 2 minus 1 minus lambda. Okay. Equals to 0. Okay. So 3 minus lambda minus, 3 minus lambda minus 1 minus lambda minus 2 times 2 equals to 0. Okay. Then 3 times minus 1, so minus 3. Here minus 3 lambda plus lambda square minus 2 minus 4 plus 4 equals to 0. Okay. Then we can rearrange this one. Lambda square minus 3 lambda plus lambda is minus 2 lambda. Then minus 3 plus 4 is minus 3 plus 4 is 1. So plus 1 equals to 0. Okay, here you can use your calculator and then you will get lambda minus 1, lambda minus 1 equals to 0. Then your lambda equals to 1. Okay, so lambda 1 equals to lambda 2. Automatic, you know this one is not linearly independent. Okay, however, you have to prove it. Okay, okay, then we have a lambda. We can find the eigenvector. Mama Eka, Mama kelas lah Mama Eka. Okay, so eigenvector 1. Okay, okay, so we have here is 3 minus 1. Okay, 3 minus 1, 2 minus 2 minus 1 minus 1. Okay, x, y equals to 0. Okay, so 3 minus 1 is 2, 2 minus 2 minus 2, x, y equals to 0. Then you have a 2, x, y equals to 2. Oh, sorry. You have a 2x plus 2y equals to 0. Okay, then y equals to minus x. Okay, if x, okay, let x equals to s, then y equals to minus s. Then your eigenvector 1 is equals to 1 minus 1 s. Okay, okay, so you have eigenvector 1 is 1 minus 1. Then here is 1 minus 1, 1 minus 1 equals to this one times this one is the minus 1 minus minus 1 times 1 minus 1. Okay, so now we have minus 1 plus 1 equals to 0. So we have proved this one is equal to 0, which is not linearly independent. Okay. Okay, so if your system is not linearly independent, then you have to find E. Okay. First, okay, E1 equals to eigenvector 1 equals to 1 minus 1. Okay, then E2 is equals to A and B. Okay, how to find E2 is you have the A minus eigenvalue times identity matrix times E2 equals to E1. Okay. Kalau saya laju cakap Okay, so what is your A? A. Okay, so this one is your A. 3, 2 minus 2 minus 1. Okay. So A is 3, 2 minus 2 minus 1 times lambda. So what is your lambda? Lambda. Where is lambda? Mana lambda? Lambda is 1. Okay. So 1 times identity matrix is 1, 0, 0, 1. Okay, times E2. E2 is A and B equals to E1. E1 is 1 minus 1. Okay. Okay. So 3 minus 1 is 2. 2 minus 0 is 2. Minus 2 minus 0 is minus 2. Minus 1 is minus 2. AB equals to 1 minus 1. Okay, then 2A plus 2B equals to 1. Okay. Okay.
Okay.
Okay. Diam je ni, saya risau juga ni. Okay. Then B 2B equals to 1 minus 2A. B equals to 1. Okay. Okay.
Okay.
Doktor boleh ke atas sikit tak?
Hmm?
Ke atas sikit.
Kata mana Ni.
Ni. Sikit je tu.
Hmm?
Sikit lagi. Sini. Okay, dah.
Kejap. Kejap Kejap Saya rasa saya salah.
Yang
Kejap.
ada letak negatif tak silap.
Dekat sini. Sebab tu saya rasa macam something wrong dekat sini. Nanti saya patah balik kat sini boleh? This part. You all tak tegur saya Okay, kat sini salah. Nanti you all kalau sempat saya identify, kalau tak sempat you all betulkan nanti. Okay, so this one is B equals to 1 tolak 2A plus divide by 2. Okay. Okay, if let A equals to S, then B equals to 1 minus 2S over 2. Okay. Okay, so katalah S equals to 1, then A equals to 1, B equals to 1 negative 1 over 2 S. Okay. Okay. Okay, so your E2 is equals to 1 minus 1 over 2 S. Okay. Okay, ini saya gantikan S dengan 1. Okay, because you have this kind of equation, then you replace S with 1. Okay, you can simplify this equation. Okay, so E2 equals to this one. Okay, then eigenvector 2 is equals to E1x plus E2. Okay, so E1x is 1 minus 1. Betul ke 1 minus 1? 1 minus 1. Okay, x plus E2 is 1 minus 1 over 2. Then this one is x plus 1 minus x minus 1 over 2. Okay, and the general solutions, okay, the YC equals to C1 eigenvector 1 exponent minus lambda. Sorry, exponent minus lambda ke? Exponent lambda 1x plus C2. Okay, so YC equals to C1 1 minus 1 exponent x plus C2 1. Okay, x plus 1 minus x minus 1 over 2 exponent x. Okay, so here this is your YC. Okay, so this is your YC. Okay, okay. Sebelum saya proceed kat sana, saya kena betulkan dulu yang ini. Mana tadi? Yang ini. Okay. So, yang ini, by right, B is not equal to 1/2. Betul kan? This one, okay. You have a 5A minus 10B equals to 1. Then your B is actually equals to 1 minus 5A divided by 10. Betul? Terbalik ni. B equals to 5A minus 1 divided by 10. Bukan yang ini. Okay. If you take this one, you make a S equals to A equals to S. Then B equals to 5S minus 1/2. Okay. If S equals to 1, then A equals to 1 and B equals to, you replace S with 1, then 5 minus 1, 4/2. Okay, so here you have B equals to, salah ni, kenapa ni? 10. Okay, so 4/10. So equals to 2/5. Okay, then B is 2/5. Okay, so this B is actually 2/5. Okay, and this one also 2/5. This one also 2/5. Okay. Yang ini faham Okay, this one because 5A minus 10B equals to 1. Not equals to 0 is the other value dia. Okay. Okay.
Okay, Doktor.
Okay. Sorry Okay, yang ini salah ni. Okay. So refer to the red colour yang colour merah ni Okay. Okay. Tadi saya stop sampai mana? Sini kan? Okay, so kita dah cari YC. Okay, now we have to find YP. Okay, so YP to notes chapter 3. Okay, so YP, okay, so kita punya YP is depends on this table. Okay, you have to look it. G is either polynomial, exponent or trigonometry. Okay, in this case, okay, our G is exponent. Okay, so if your G is exponent, then you can use this one. Okay, U1, U2 exponent lambda X. Okay. Mana? Okay. Okay, so ini kita punya apa ni? G. So this is our G. Okay. Okay. So YP is equals to U1, U2. Okay. U1, U2. Okay, exponent lambda X. Okay, depends on this G lambda. Okay. Exponent lambda. So in this is a minus X. So exponent minus X. Okay. Okay, so you compare this YP with YC, the pattern. Okay, so the pattern is the same or not? Patternnya sama ke tak?
Tak sama.
Tak sama kan? Sebab this one minus X, this yang YC is X, betul? Betul? Betul ke tak betul?
Betul.
Okay, so kalau tak sama, you terus boleh pakai this YP. Okay, so you terus pakai YP ni. Okay, so next step, apa you nak kena buat? So next step,
Differentiate.
you differentiate YP. Betul? So YP prime, you differentiate, you dapat?
Negative U1, U2, E. Bawah
Negative
negatif.
U1 exponent minus X, negative U2 exponent minus X. Betul?
Ya.
Okay, so next step. Next step, you gantikan masuk dekat dalam mana? Mana? Kat dalam sini, betul? Betul kan? YP prime equals to A YP plus G. Kan? Okay. Okay. So equation asal you adalah Y prime equals to A Y plus G. Okay. So now you replace this YP prime equals to A YP plus G. Betul? Betul? Okay. Okay, so YP prime. Okay, negative U1, negative U2, exponent minus X equals to A. So what is your A? A is 3, 2 minus 2, 1. So 3, 2 minus 2 minus 1. YP is U1, U2, exponent minus X plus G1 plus G is G is okay 2 1 exponent X. Exponent X ke? Exponent minus X. Okay. Okay. So, this one. Okay, pemudahkan yang ini. 3 U1 plus 2 U2. Okay, minus 3 U1 minus U2 exponent minus X plus 2 1 exponent minus X. Betul? Sama juga dengan?
Doktor.
Ya, saya.
Negatif 2U2.
Mana kat mana?
Kan? Betul tak? Yang
Yang ini Okay, thank you. Negatif 2 U1 minus U2. Betul kan? Okay. Then,
yang atas tu sama.
yang atas salah kat mana lagi
Yang
Mana?
yang atas tu.
Mana?
Dia minus 2U2 kan?
Minus 2 U2 yang kat mana?
Sini. Equation. Yang atas tu yang tadi doktor betulkan tu.
Yang mana?
Yang masukkan dekat ni. Masukkan dalam equation yang tadi tu yang doktor betulkan tadi.
Yang ni ke?
Bawah dia.
Yang ni?
Kan dia 3U1 minus 2U2 kan?
Dia yang ini darab yang kejap. Ni darab ni tambah ni darab ni kan?
Bukan atas bawah.
Atas bawah ke?
Sebab hari tu yang
Tak.
doktor tak tahu.
Saya salah
Itu saya tak sure sebab yang hari tu doktor buat atas bawah.
Dia sebelah kan? Dia ini darab ni kan?
Ya betul.
Ini darab ni.
Okey.
Nanti cuba tengok balik. Okay. So 3U1 tambah 2U2. Okay. Dia akan jadi 1. Okay. Tolak 2U1 tolak U2. Okay. Kat sini. Okay. Then 3U1 tambah 2U2 tambah 2. Okay. Exponent minus X. And then minus 2U1 minus U2 plus 1. Okay. Then yang ini minus U1 minus U2 exponent minus X. Okay. So ni, okay, minus U1, okay, equals to 3U1 plus 2U2 plus 2. Okay. This one you bawa ke sini. Okay. So now we have 2U2 equals to 4U1 minus 2. U2 equals to 2U1 minus 1. Okay. Okay. Kalau salah nanti betulkan ini saya bawa ke sini jadi salah kan? Jadi negatif 4U1 minus 2. So negatif 2U1 minus 1. Betul kan? Betul tak? U2 equals to minus 2U1 minus 1.
Betul.
Betul Okay. Yang bawah ni minus U2 equals to minus U1 minus U2 plus 1. Okay. This is a equation. Okay. This one. This one. So U2 cancel kan? U2 bring to this side jadi positif. Positif tolak ni. So cancel. Now you have 2U1 equals to 1 and U1 equals to 1 over 2. Okay. So U1 equals to this one. You replace masuk dekat sini. Then you dapat U2 memang kosong. Betul? U2 kosong ke? Kejap kira balik. U2 equals to minus 2. U1 is 1 over 2. Minus 1. Tak kosong. This one equals to minus 2. Then your U2 equals to minus 2. Okay. U1 equals to 1 over 2. U2 equals to minus 2. Okay. You masukkan dekat dalam ni. This YP. Okay. So YP awak sama juga dengan YP equals to U1 1 over 2 U2 minus 2. Okay. Exponent minus X. Okay. So you have YP and also you have YC. Then your Y equals to YC plus YP. Okay. So YC is C exponent X plus C2 exponent lambda 2X plus YP. Okay. So YC kita tadi C1 1 minus 1 C1 1 minus 1 exponent X plus C2 X plus 1 minus X minus half X plus 1 minus X minus half. Okay. Exponent X plus YP is 2 sorry. YP is 1 over 2 minus 2 exponent minus X. Okay. Ada soalan?
So takat ni
Ada
tak
soalan?
ada.
Takat ni tak ada. Senang kan? Kan? Okay. Next. 6 dengan 7. Okay. 6, 7, 8. Okay. Metodnya sama. Cuma sorry. Cuma dia difference on the value only. Okay. Method. If you follow the method, you can get the answer.
Doktor,
Okay.
tadi doktor buat untuk method undetermined kan?
Memang pakai method of undetermined sahaja untuk chapter
Yang
3.
sebelum ni punya doktor, yang untuk 3 punya, soalan 3.
Soalan 3. Soalan 3. Ini homogeneous.
Homogeneous. So doktor, macam mana kita boleh identify yang ni homogeneous ke atau yang ni undetermined macam tu doktor?
Okay. Homogeneous is a system. Okay, your system. Okay, your system have a two. Saya cakap apa? Two types of system. Okay, it's either homogeneous or non-homogeneous. Okay, it's either homogeneous or non-homogeneous. Boleh nampak tak saya punya slide? This one. Okay. Okay, homogeneous. Okay. Your system is homogeneous if mana saya punya system. Okay. Kalau awak tengok dekat sini. Okay, dekat sini. Okay. Awak punya sistem, dia akan ada satu GX. Okay. Kalau GX awak ni kosong, which mean your equation is something like this. Like this. Okay, Y1 equals to this one. Okay. Dekat sini kalau you tengok dia tak ada GX. Okay. Dia cuma ada Y1 and Y2 sahaja. Okay. So, kalau bentuk sistem yang macam ni, this one is a homogeneous system. Konsepnya sama macam chapter 2. Chapter 2 kita belajar, we learn about the homogeneous equation. Okay. If homogeneous equations, okay, you have to look at the fx. Okay. If fx is 0, then that is the homogeneous equations. So, same goes to the system. If gx is equals to 0, then your system is homogeneous. It just have a y1 and y2. Okay. If your gx, okay, is not equals to 0, which means you have a gx, okay, your system will be like this. This is a non-homogeneous. You see, there is a gx here. This is a gx. G1x and G2x here. Okay. This
So
part.
yang
Sorry.
so doktor yang non-homogeneous tu semua kena guna macam formula yang doktor guna dekat soalan 5 kan?
Non-homogeneous soalan 5, mana soalan 5? This one.
Ya.
Untuk non-homogeneous, okay, you have to find YP. YP. Okay, so YP, okay, depends on this one. This one is G, right? This one is GX. Okay, so YP, you punya YP, it depends on these types of G. It's either polynomial, exponent, or trigonometry. Okay. If a non-homogeneous, okay, you have to find the YC first. YC is you get from here, from homogeneous system. Okay. Once you get YC, then you can get YP from here. Okay, this YP you have to identify whether it's polynomial, exponential, or trigonometric. Okay, you have to refer to this table. This table to assume YP. Okay. Okay. Ada soalan tak? Ada soalan lagi tak? Ada soalan?
Okay, doktor.
Okay. Faham Faham? Okay, you all boleh try sampai habis soalan tutorial ni. Okay, jawapannya dah ada kat dalam modul. Okay. Okay, so kalau tak ada soalan, saya stop kelas kat sini. Okay, so we will have a next class on Wednesday. Wednesday tak cuti kan? Okay, so this Wednesday we will have class. Okay, saya tak akan buat tutorial hari Rabu ni. Saya buat kelas, okay, untuk next chapter, chapter 4. Okay, Laplace transform. Okay. Okay. Okay, kalau tak ada apa-apa, saya stop sampai sini.
Doktor.
Ya, saya.
Nak tengok dekat soalan 3 tadi.
Ya.
Yang kita buat tadi.
Yang soalan 3 yang mana? Yang saya betulkan tu ke?
Tapi nak tengok yang mula-mula tu, yang kita cari lambda tu kan.
Ni. Ini.
Yang masa kita lepas masukkan dalam bentuk matrik tu. Bawah sikit.
Ni.
Bawah sikit lagi. Okay, ni. Kan kita dapat dia punya equation tu lambda squared 6 lambda ni tambah 8 kan. Tapi kalau saya punya lambda 1 dengan lambda 2 tu terbalik tak apa kan? Sebab saya dapat
tak
lambda
apa,
1
sebab jawapan kat
boleh
dekat
kan?
sini sama je kan? Tak kisah. You terbalikkan si 1 si 2.
Macam tu lah.
Ya.
Terbalik kan boleh
Ya.
Okay.
Boleh. Even you punya ni. You punya X dengan Y ni pun kalau you terbalik pun, kalau you this one kita assume X, let's say you assume S, Y equals to S, then you punya jawapan pun akan terbalik juga.
Okay, baik.
Okay.
Terima kasih.
Okay, ada lagi soalan?
Madam, saya nak tanya.
Ya.
Tapi bukan untuk ni lah. Bukan untuk saya nak tanya pasal assignment. Okay, kan kita prove tu boleh saya screen ke madam? Saya nak tanya something. Tak apalah. Sebab dia ada satu soalan dia macam ada guna I dengan T. Dia tak guna Y dengan X.
Sama
tapi
je.
bila saya sama je kan. Sebab bila saya nak try buat solution tu dekat online, dia tak boleh baca kalau I dengan T. Dia boleh baca Y dengan X saja. Boleh kan?
Itu akan Y dengan I dengan Y, T dengan X.
Okay. Itu untuk proofkan je lah kan. Tapi jalan kerja kena guna I dan T.
Jalan kerja kena guna I dengan T. Okay, sebab tu dia nak kira current kan?
Okay. Terima kasih. Itu je.
Okay, ada lagi soalan? Any question? Okay, if no question, so kita jumpa next class hari Rabu. Okay, so stay safe semua. Okay?
Okay, doktor. Terima kasih.
Okay,
Terima
thank
kasih.
you.
Thank you,
Okay.
doktor.
Thank you, doktor.
Okay.
Thank you,
Okay.
doktor.
Okay.
Thank you, doktor.
Thank you, doktor. Assalamualaikum.
Okay. Dah, kenapa?
Nak buat doriyaki,